Hello everyone, I'm Bartłomiej Hirsz and I'm QA and DevOps specialist from Poland. I have several years of experience in embedded and banking in all levels of testing. I started using Robot Framework a few years ago and from the very beginning I tried to use it together with Python, starting for creating my own libraries, listeners and also tools. Recently, I started contributing more to open source. I'm co-author of Robocop and Robotidy tools that were shown in other talk, how to avoid jail for the nasty code. And today I will be talking about new parsing API for Robot Framework and how to create your own tool. So, how actually Robot Framework parses the code internally? Robot Framework and Python use similar approach for interpreting the code. First, the code is converted to sequence of tokens, and this process is called tokenization or lexing. And depending on what we have, we end up with different token types. For example, in Python, the word import implies that we are dealing with the token of type import, and the next word after that will be the name of the module to be imported. And in this example on the screen, we have short robot code. The lexer knows that if the line starts with the asterisk, we most likely have the header section. Then it tries to validate and parse the current line and create header token. The current context is saved, so in the next line, Alexa expects to find the settings token, and the parser for them is used. In case of keyword section, we are expecting to find keywords or comments and so on. And on the right, we can see how this code is parsed to individual tokens. Those tokens create sequences that can be defined as statements. In this case, setting header and end of line tokens create section header statement. And sequence of statements can create block. In this case, section header and library import creates setting section block. And statements are used to create AST, abstract syntax tree. It consists of nodes linked together in form of tree. AST is used in most programming languages to represent structure of the source code. The previous robot code example is represented here as AST. We can see a file node that consists of two nodes, settings and keyword section. Keyword section contains one keyword, which contains one keyword call. Finally, keyword call is created from the list of the tokens on the right. And in the robot framework, parsing API, we also distinguish nodes between blocks and statements. Each of them is created from the list of tokens. And with AST, we can get advantage of visitor pattern. In this case, if we define a visitor that should be triggered on keyword call, our visitor algorithm will visit all nodes starting from the top until it reaches node that we are looking for. When our method is called, it receives the node data so we can manipulate it. In case of robot framework, we are creating internal models, later on use it to execute tests. But in our case, and with help of public available API, we can do pretty much what we want. Robot Framework have ready-to-use public parsing API that enables you to parse the robot code and your program. You can find documentation for parsing API under this link. It's quite long, so you can use generated QR code or just Google Robot Parsing API. If I open the page, you can see all the necessary information, how to use it together with examples and more detailed docs. For example, here is the section how we can parse source code to the list of tokens. It's not that useful and probably will be more interested in pasting data to model, like shown here. This code parses the model and pre-print it. So let's try it. I have prepared a robot file which contains two test cases and one keyword definition, and also Python file print model, which is copied over from the example in docs. Let's try to run it. You can see that all nodes are here, and we have the file node, which contains all attributes like source, line number, call offset, and so on, and also sections, test case section, which contains test cases, and so on. Since the model is tree structure, you would need to create your own traverser to get the nodes you need, for example, test case. But IST module already have prepared visitors for you. It's described under Inspecting Model section in docs. So let's see this by example. Important note is that when we are parsing the source code, we don't have that much of context when we are parsing the test. So in this case, in both test cases, we are calling keyword with the name some keyword, and it will be represented as keyword called node. But this node will not have the child node with the definition of some keyword, because it could come from the dynamic test library or some other resource file. So we need to find the definition on our own. Thankfully, this keyword is described in the same file, so let's try to reach that. We have the empty visitor py file, and we'll be using the AST module to get the AST node visitor. And also from the parsing API, we'll import get model to get the AST model of robot source file. Then we need to define our visitor, which inherits from the AST node visitor. And this visitor should implement methods that starts with the name visit and then with the name of the node that we want to visit. For example, visit test case and so on. But we want to visit keyword, so let's go with the keyword. And also this should be case sensitive. We will accept one argument, the node. And let's do nothing. Okay. Then we need to create AST model. And we need to create instance of our visitor. We can reuse the same instance of visitor if we are trying to parse multiple files. Then we need to use our visitor to visit our AST model. Okay, so let's try to put a breakpoint here and see what happens when I debug this. Okay, we can see that we got the node object, which contains the body and various attributes. For example, end line number 11. We can see that this some keyword actually ends in the line 11. And also it contains arguments and log. You can see this also in this in body, that we have the child nodes arguments and keyword call. And if you want not only to read and also modify your model, you can check the modifying token values section in Robot Parsing API. There are quite nice examples, code examples, how you can use that to modify your model. In this case, we have the keyword rename that finds the definition and calls of some keyword, and then modify the token values to replace those names for new name. For example, the keyword is replaced by new name, and in the name in the end, when we call the save on the model, we are saving the changes back to the disk. And if you want to the bigger changes to model, for example, removing whole sections, test cases, keywords, it's better to use the AST node transformer instead of AST node visitor. And there are also examples how you can use it in Python code. Okay, I think that's it from the theory side, and I can show you how I use that Robot Parsing API in my tools, Robotidy and Robocop. Robocop and Robotidy were described in other talk, how to avoid jail for the nasty code. But in short, both are still young open source projects related to code quality. And on the screen, you can see our two fantastic logos. Robocop scans the files to analyze for any issues, like pilint for Python. And Robotidy how to format the code according to set of rules, like black for Python. And I will show you their source code in the core as an example of using Robot Parsing API. So Robocop. This is the project, of course, written in Python, and it uses the robot parsing API under the hood. Of course, we have a lot of code related to all of our features, but our core use the robot parsing API, which is our visitor tracker. This is the class that visit robot framework nodes and checks for any issues. And it inherits from AST node visitor and base tracker, which just contain some internal methods for reporting or registering rules. And to see how we can how we use that, for example, for other rules, we have the class return tracker that inherits from that visitor tracker. First, we describe what rules we have. Here we have the message ID, message name, and message description, and severity of the rule. Then we just simply visit the node that we want. In this case, we want to check the return statements in keyword. So we visit keyword, and we are going over the keyword calls in the keyword. To see if, for example, we are trying to call a return like here without any return values, or we are we are calling the keyword after the return, and so on. Because, for example, we also have the nested for loops checker, which just check if we have the nested for loops. Before the robot framework 4, it was the error. So in our case, we just need to visit for loop, and then we just need to check if in the body we have the other for loop nested. So if that happens, we just self report this, and that's all. So you can see that the actual code for visiting and reporting is very simple, and I actually create the Robocop in like 1 day, thanks for robot parsing AI. And then, of course, extending the whole tool took me a lot longer, but just the basic functionality, thanks for parsing APIs, was very simple to implement. And as for Robotidy, the core code looks even simpler. Of course, we have the wrapping code, for example, for parsing the commands from the command line. And we are code for reading the source files to the model, then creating instances of our visitors, visiting and saving it to back to the disk. But our core code uses the parsing API directly. For example, we have the transformer discard empty sections. Let's open this. And it inherits from the model transformer, which then inherits from the AST node transformer, and it from the visitor finder, which is a helper class for easier finding your node. And in case of this transformer, we want to remove any section that is empty, and it is considered empty if there is no data in the section or there are only comments, except from the comment section. So you just need to visit section node, and then we are checking if section contains anything else than empty line or comment. If yes, then we want to return node unmodified because the section is not empty. And in other case, we are returning none. Because in case of AST node transformer, like I described it in docs, if you return node from the visitor, it will remove given node from the AST tree. And that's actually it. And if you want to transport in Robotidy, you just need to create your own transformer class and visit the node that you want to transform. For example, change the values of the tokens or remove something. Then just write the code for that, and does it. Quite simple with robot parsing API. And it's time to use all that knowledge to create your own tool. I have prepared one problem, which actually was a question asked in the forum, and I have used robot parsing API to implement this. So let's jump to the code. So the tool for removing test cases that contains tag deprecate. Imagine that you have an older project with thousands of suites with several hundreds of tests, and at some point of time you started adding the tag deprecated the test cases that were covering the features that were removed from your application. And now you want to clean up all that mess and remove those test cases that contains this tag from your code base. And of course, you can do this manually. Just remove this safe and that's it. But if you have thousands of files, it would take several hours or even days. So it's better to use some automation solution. And I will create a tool for that using the robot parsing API. So I have the empty main.py file, and I will be using the AST module. And from the robot API, I will import get model. Then I will create our visitor class, remove the deprecated test, and I'll be importing from AST node transformer since we want to transform our model. And we will be going through all the test cases and looking for tags. So obviously I want to visit node test case. And for now I will return unmodified node and create model first, get model, and yeah, you can use fixed file path for now. Test a robot. We want to create an instance of our visitor and use that to visit our model. And in the end, I want to save that modified model back to a file. I point this to the different file. Let's call this result robot. So it'd be easier for us to compare results. First, I put a breakpoint here so I can see what's inside this node if I run this code. I think I made mistake here. It should be let's again. Okay, so we have the node of type test case like here, and it have three child nodes: the tags, the keyword called, and empty line. And the tags could be on any place, so we need to actually iterate child nodes in our test case node to find this. So how to find this? Let's go to this tags. Oh, we have the attribute type with the name tags, so we can look for that. If child type equals tags, or actually let's reverse that. If it not equals, we want to continue. And otherwise, we want to check this tag node to see if you have deprecated tag. Of course, we can go through the tokens, but we would need to parse everything like separators, the setting name, empty line. But thankfully, here is the attribute values that contains the tuple with the tags inside this node. So we can check that. So if deprecated in child values, then we want to return none. Because if you return none from the AST node transformer, it will remove given node from the AST tree. And if you return the unmodified node, it will just do nothing. Okay, we can try to run this code. Here we have the results robot file. We can compare that with our source file, and here we can see that our source file contains the test case with the deprecated tag, but our output does not, so our tools work. So for now we can try to modify this code so it will work with the directories and it will iterate through the files. For that, I'll be adding the import system. So because I want to use the sysarg for arguments, I need to I need to add argument to our Python script. It will be the name of the directory that I want to go through. And I want to create some kind of function for iterating the paths. You can also use pathlib from pathlib import path because it is quite handy to use. If path is file, let's make a generator from that. So I will just yield path if it's file, and in other case, if path is directory, I want to yield from I want to iterate from file here yield from get paths file. Let's fix typos. Always a lot of them. Okay, I want to check what I actually get in the command line. Okay, so I have it here in the second place. So for path in get paths, let's create path from the sysarg second place. I want to create a model from that file. So I need to replace this fixed path with our variable. I think I need to change path object to string. Then I actually need to create instance of our visitor just once. Let's put this before the for loop. Then I want to visit this model, and I want to save results back to the disk. But I want to use this path instead. So by default, it will be saved at the same file, but in our case, I want to compare this. So I will just modify the name a bit. Okay, it should be enough. So let's try to run this. I got permission denied. Let's try to debug this code. So okay. It is method, so we need to call it like that. So run it again. Okay, let's check the source code. You can see that it creates the file next to it. So we can easily compare that. In this case, it removed the deprecated test cases. Here also it removed the test B that contains the deprecated tags. How does it? We have a tool that removes the test cases with the tag deprecated with just few lines of code. If you remove that, it will save back to the file, so it modifies in place. Thank you everyone for listening, and I hope it was useful or at least interesting to you. I'm open to questions in QA part after this video, but you can always reach me through the email, LinkedIn, or Robot Framework Slack channel.
Hey Bart, welcome back to RoboCon.
Hi.
Great to have you. So the questions are coming in, so let's get right to them. First one's from Jan, wants to know, does comments, the pound sign in robot files, are they kept during transformation?
I think it's about the transformation in Robotidy,
Yeah.
but yes, they are captured in the model. So you can use that to modify the comments or do some actions based on that.
Great. Tadu wants to know, Which robot framework does Robocop and Robotidy support? Or which robot framework?
So Robocop supports the robot framework 3.2 and 4, and depending on which version you use, you could get a bit different rules because there are some changes like nested control structures, handling, or if blocks. So depending on the version, you get the different rules. And Robotidy for now supports only Robot Framework 4.
Cool. Next question is, can I remove deprecated test cases, but what about its keywords? Is there a way for the tool to indicate test case keywords, which can also be removed as they have no dependence, and also keywords which cannot be removed as other test cases depend on them? I don't know if you got all that, but I can reread it if necessary.
I think I could just answer this with yes, you can.
Awesome. Great. Next question is how to modify existing test cases which don't have tags.
Yes, you can. It's not depending on the tags or whatever. It was just an example of using the robot parsing API.
Nice. Can we use these APIs to update the user test data in robot files?
Yes, I actually use that while refactoring a lot of tests. Like I had like 1,000 of tests, and they're very similar, and they have some test data inside, and it did change. So I could just use some very complex regex for that, but I just used a simple robot parsing API script that just search for variables in given keywords and replace the values. So yes, you can use that.
Tristan wants to know, can we use the robot API parsing to generate a pie chart on report analysis automatically? And if so, what steps to take?
The pie chart?
Yeah, wants to know, can you use the API parsing to generate a pie chart on the reporting analysis automatically?
Yes, you can. For example, I also use the robot parsing API to upload our test cases into our Jira, or we can use to upload it to different system database and store the definition of your keywords and some analytic, like for example the tags or any other data that is used in the robot framework test. You can export it in any format you want, since it is just pure Python after parsing this.
Cool. Manny has a question in Slido. He wants to know, does it make sense to use the parsing APIs to refactor your .robot test suites? Example, if you want to migrate a project from Selenium to browser, to me it seems safer to use the parsing APIs that you showed instead of a global search and replace in an editor.
Yes, exactly. I think it is better to use the robot parsing API, especially that you can normalize the names, because the robot is very flexible if it comes to the names. So, for example, the snake underscore case or snake space case with the big uppercase is the same for the robot. So you would need to create some monster regex for that. So I think it is safer to use the robot parsing API.
Great. Simon wants to know, removing test cases would also be possible with the listener API. Are there advantages to using the parsing API?
The listener is used during the execution. So first you need to execute the test, and it will just like filter out the test cases. It will not change them in the disk like you want to do in this case. And of course, it is a lot faster to experiment and do anything with parsing API rather than trying to do with listener, especially if you have a lot of tests that are taking hours to run, and not all of the test cases are run in one run usually. So yeah, so it's a bit harder to use listeners for that.
Okay, I'm 2 minutes over, so I just want to get to these other questions really fast. This one's a Slido. They want to know, can I use the parsing APIs to report actions?
Well, I don't know what action that you want to report, so I cannot answer that.
Good. That's a quick answer. Is there any alternative result libraries that we can use instead of the standard log format?
Instead of standard formats?
Instead of the standard log file format. So is there any alternative results libraries that we can use instead of the standard log file format?
No, but you can create your own library using this approach. Actually, the results are also using the parsing API, so you can create visitors for results and like go through your results and search for something in your HTML file. Instead of parsing the HTML file, you can use the visitor that is available for you in the Robot API.
Awesome. Thanks again, Bart, for contributing to RoboCon. We have a few other questions, but I'm sure people can see you in the RoboCon venue during the break. You're going to be on the light side or the dark side?
Yeah, dark side. I'll be in the dark side.
Perfect. All right, cool. Thank you again, Bart. I really appreciate you and all you've done this year for RoboCon with the 2 sessions. Thanks.
Thanks.
Cheers.